Electronic Specifier.
Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Joseph Notaro, Vice President of Global Sales and Marketing at Dukosi. We talk about how Dukosi's cell monitoring system, the DKCMS with C-Sync, is redefining how batteries are monitored, managed, and offering improved safety, efficiency, and performance. Dukosi's innovation has not gone unnoticed. It recently won Electronic Specifier's Electronics Excellence Award at Embedded World 2025, and we'll be discussing what this award means for the company's future. I hope you enjoy this episode. Let's get started.
Electronic Specifier.
Welcome back to Electronic Specifier Insights. Today, I'm pleased to be joined by Joseph Notaro, who is the Vice President of Global Sales and Marketing at Dukosi. So thanks very much for joining us, Joseph. How are you today?
I'm doing fine, Paige. Thank you for having me.
You're very welcome. I'm good, thank you. The sun is shining, so it puts me in a good mood. Joseph, why don't you introduce yourself for us before we get started?
So, yes, like you said, my name is Joseph Notaro. I'm the Vice President of Global Sales and Marketing at Dukosi. Been at Dukosi for almost 2 years now. My home base is in Munich, so today's a beautiful sunny day as well, so enjoying it. But like I say, my home is the Munich airport because I have a global role. Teams are spread out across the world. But besides that, previous to Dukosi, I have more than 30 years experience in the semiconductor industry with big names and smaller companies. So.
Excellent. And can you tell us a little bit about Dukosi as well? Tell us what the company does.
So Dukosi is a company that's headquartered in Edinburgh. And really the focus and the mission of Dukosi is to develop technologies and solutions that dramatically improve the performance, safety, reliability, and cost-effectiveness of battery systems, while also enabling sustainable and circular battery value chain. The company is first to market with its unique chip-on-cell technology, designed from the ground up, and it's ready for next-generation batteries to power applications such as EVs, stationary battery energy storage systems, and industrial transportation.
Brilliant. Thank you very much for that introduction. And today we're going to dive into the future of battery management with your cell monitoring system, the DKCMS with C-Sync. Now, this technology is redefining how batteries are monitored and managed, offering improved safety, efficiency, and performance. And this innovation hasn't gone unnoticed. So recently you won our Electronics Excellence Award at Embedded World 2025. And we'll discuss what this award means for you, as well as what makes the system stand out and how it's set to impact key industries. So, Joseph, why don't you start by giving us an overview of your cell monitoring system and what you think sets it apart from traditional battery management systems?
So DKCMS is a unique contactless battery cell monitoring solution. And it consists of different parts. There's the cell monitor chip, a system hub chip, the Dukosi API, and what you mentioned earlier, the C-Sync. So we basically put a cell monitor on each series cell in a battery pack, which provides accurate monitoring of voltage and temperature of every specific cell. And it also does all the diagnostic and the cell balancing functionality. The system hub is basically managing the communication that comes from each cell, and it gives that data to the BMS host. And we're using a proprietary communication protocol, which is called C-Sync. And the DKCMS allows to optimize battery performance, safety, scalability, and longevity of batteries. And it does it in a unique way. When we look at traditional systems with far-field or wired solutions, you don't have that synchronicity of the measurements. You don't have the accuracy of the measurements, and you don't have also the security of all the information that you're giving to the main BMS host.
So how exactly does it improve battery performance, safety, and lifespan?
So one key aspect is the location of our chip. As mentioned earlier, we are directly on the cell, mounted as early as possible in the process. So being directly on the cell, you can have more accurate. You can sense the state of the cell in a more accurate way. Obviously, you don't have long wires, you don't have a lot of interference, but also one of our key IPs is the ability to accurately measure the cell's parameters. So that's really part of our IP. The other aspect is how we transmit the data. The data we collect is transmitted via C-Sync, and like we mentioned, C-Sync is a unique protocol that provides highly secure and extremely robust and reliable network. And it also provides inherent electrical isolation and security throughout the whole network. So basically, we're decoupling the low voltage, high voltage domains, making the BMS safer and easier to implement. And it is our patented communication protocol based on near field technology, and it provides that immunity to external interference. So really robust in any field. So be it in automotive, be it in industrial transportation, be it in an airport or an energy storage system. And unlike traditional wired and far field wireless systems, we don't require complex wiring harnesses and associated connectors. And the contactless solution also overcomes the limitations of traditional systems, and it frees up design constraints to provide greater safety, design flexibility, scalability to designers. And it's that unique combination of extremely accurate and synchronized measurements allows the BMS brains to more accurately estimate whatever you want to estimate, to be a state of charge, state of health, state of available power, and of each cell, and translate that into really more usable energy per cell. So that could be more range, better lifetime management of the cell, performance of the pack, better cost, because you'll need to over-dimension the cells. So it's a unique combination of how we sense the data, how we transmit the data, and how we store the data.
So what role does C-Sync play then in ensuring synchronized and secure data transfer across the system?
So it's basically also in the name, C-Sync, C-Syn and the capital Q. The C stands for cell-based monitoring analytics. The Syn for synchronized measurements and communication. And Q is a universal symbol representing electrical charge. So how do we move charge from cells to the application? So C-Sync delivers like wide-like performance and the star network behavior, while the system hub is managing the bidirectional data transfer between all the cell monitors and the BMS host via single bus antenna. And that single bus antenna sits above each cell monitor and connects the cell monitor to the BMS host via the system hub. And you could transmit data that's accurate, granular, because it comes to each cell, and more than one data per cell, and with predictable latency. So that combination of synchronization, deterministic latency, and granular data is really the differentiator versus what the competition can do today.
So following on from that then, could you explain how the DKCMS addresses challenges such as cell-to-cell communication and data accuracy?
So, like I mentioned, C-Sync is the protocol that was designed specifically from the ground up for safety-critical multi-cell large battery packs. And that's what was designed at the heart of the DKCMS. It provides deterministic communication with the synchronicity from all cells. And we want to give data to the BMS so they can make the optimal decisions. So giving more data, more accurate data, granular data. And I like to use the analogy, with CMOS image sensors. You could have a rolling shutter, global shutter. Rolling shutter is easier to implement. You have less data, but you're scrolling from one row to another. When you have highly dynamic situations, like you could have motion artifacts, for example. So the image is not clear. It's not really what you're expecting. While global shutter takes an image, all the pixels at the same time. That's what we're doing. We're basically able to take an image of every cell at the same time. So even in dynamic situations, we give the BMS a clear image of the cell conditions every time that snapshot is taken. So that is really the differentiator and the core out of our technology, to be able to give that snapshot very reliable, very accurate, very granular of each single cell in the pack.
That's very impressive. And what about a topic that's sort of growing in importance now, which is sustainability? So how does the DKCMS contribute to sustainability and efficiency in battery-powered applications?
So as we know, the global battery value chain is embracing a circular economy. We need to do that. We have so many now, after so many years of EVs, to predict, I think, more than 100 million EV batteries in the next decade that need to be repurposed or recycled. What do we do with that? So we have this moral duty to find a way to make this more sustainable. There's some regulatory requirements coming in for traceability at the battery level, at the EU battery passport. Other regions, including China, US, are following, developing their own versions. But what we believe, and also many of our customers believe, full traceability can only be achieved at the cell level, that you don't need to rely on the BMS being connected to the battery. And I mentioned earlier, we sense data more accurately. We provide data in a safer way. The third part of our solution is storing the data. So the Dukosi cell monitor, which is attached to each cell now, we have dedicated on-chip memory, and that acts as the cell passport. You could store lifetime traceability data, including your unique ID, materials provenance. And as long as the cell monitor is attached to the cell, you have that information. It's always available. So you don't need to have a BMS that's connected. It could be outside the vehicle. It could be, then this allows you to repurpose the battery, allows second life, enables second life in a more, economically feasible way. And like I say, it's almost like Las Vegas. What happens to the cell stays on the cell. So you're driving it, and we're making batteries more sustainable, one cell at a time.
That's brilliant. I love that. So you've mentioned EVs already, but what industries or applications do you see benefiting the most from this technology?
So all applications that require large batteries, large battery packs. It could be, we said EVs, definitely, that's a major market. Energy storage systems, it's also another major market for large battery packs. But there's also a group of applications that maybe go unnoticed, but it's very interesting. You have like airport ground service equipment. And actually, this is one of the first applications we'll be in production with. You have marine applications, be it large vessels or even yachts. You have forklifts, mining equipment, construction equipment. So a lot of applications that they require not only large batteries, but they require more efficient batteries, and applications that may not have large volumes in terms of battery packs. So you need also the ability to have scalability. And that's what we provide the customers, because now you have one chip on every cell. You could use any cell to pack configuration you want, and you adapt it to your end application without having to redesign the whole pack.
I'm interested to hear your thoughts, Joseph, on how Dukosi sees the future of battery management evolving and where you also see the DKCMS fitting into this landscape.
So until now, legacy systems have been just trading off performance, cost, safety, and sustainability. And many of today's systems, they're based on old battery designs that were used in other applications, laptops and mobile phones, and you just extend that to large battery packs. So you have like modular type of designs, and they were not really they were really focusing on doing something, getting to market, but they're not really optimized. And that's what we did. We took a step back and we asked ourselves, okay, what does the industry need? Not now, but in the next 10 years. And that's why we're disrupting the industry. So battery management systems will need to provide better estimates. We said state of charge, state of health, state of available power, and to make sure you need those estimates to extract the most out of a cell. Lithium, raw materials, they are not unlimited. We want to recycle. So there's two ways. Extract more out of the cell today, you don't need to over-design your cell, then you could have a second life. And we see, and you mentioned how battery management systems are evolving. There are trends to leave it as an independent function, or to integrate that maybe a central compute engine. In a vehicle, there's so much talk about software-defined vehicles, maybe a central brain. But at the heart, you still need the data. And you still need data that's very accurate, that's synchronized, it's granular. And that's the only way to meet the performance, the cost, the safety, and sustainable targets without any compromises. And that's where we come in, because we provide additional data that's granular, accurate, synchronized, and it's helping address not only today's problems, but also next generation as well.
I think given all that you've said so far, Joseph, it's very clear that you've got a very innovative product on your hands here, and it's a no-brainer as to why it won our Excellence Awards at Embedded World. I know the judges were very impressed with it. So what does winning that award mean for the team at Dukosi?
So when you develop a new technology or you have a new solution, obviously you're convinced of its value, or else you wouldn't be developing it. But as they say, the proof is in the pudding. So Only when you show the customers and the industry experts do you really have the confirmation of how valuable it is. Electronic Specifier Excellence Award is one of those validation milestones for us. It's an industry expert that's publicly validating what we thought. So it's really an honor to receive this award, and it confirms that the efforts of our entire team were well spent. But allow me a moment of pride here. The fact that this award is even more special since we won against one of our main competitors, an industry leader with a product for the same application. The fact that Electronic Specifier chose our solution over theirs makes us even more proud. So
Yes,
thank you very much for that.
You're very welcome. You should definitely be very proud of yourself. So what's next for Dukosi then, following this achievement? Are there any new innovations or expansions on the horizon?
Absolutely. And this is only the first step. And really, we want to have a product that goes to market. But we have a complete roadmap that's focused on improving the performance, cost, safety, sustainability of batteries. We'll be introducing in the next months, next quarters, additional sensing elements, while also adding analytic capabilities to our devices, giving battery developers the more data to make the right decision to prove those criteria we mentioned earlier. So there's a full roadmap. We're working with key customers as well on that. And you'll be seeing many announcements in the next quarters to come.
Excellent. I look forward to it. So before we wrap up then, Joseph, is there anything else that you'd like to discuss?
So I'd like to thank you, Paige, for this opportunity, for this podcast, and also Electronic Specifier for the Excellence Award. We've come a long way in these past years, but having recognition from the market, we just received our first production orders, so that's something we're proud of. We made an announcement a couple of weeks ago, and having a recognition from industry experts like yourself is a true honor, so thank you very much.
You're very welcome. It's been a pleasure having you as a guest, and thank you very much for doing a deep dive into Dukosi and your innovative product. So thank you very much.
Thank you very much. Have a great day.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.
Electronic Specifier.